Welcome to our presentation. My name is Eric Ellsworth, and my teammates are Philip Tolero, Thomas Chen, and Alex Rusu. Today I will be highlighting the key aspects of our analysis, walking through an example of how data analysis can add value to your company, and we'll be providing a conceptual interactive alternative for managing the data. For this project, we examined a dataset from testfreaks.com. The dataset mainly contained HP product reviews, which was the focus for our analysis. The TestFreaks website, which pulls product reviews from over 60 countries and tens of thousands of websites, provides an aggregated score on a scale of 1 to 10 for each product. In this instance, the data was not only from 1,100 different websites, but also contained reviews in multiple languages, which required additional translation. Some sentiment characterized as pros and cons were categorized using key terms such as overall quality, features, and performance. Google Sheets was used to translate and organize the data. It provided a means to store user reviews without any field or character limitations and to export the data in a variety of formats. On the left, you can see that there are two columns for the header named extract. The extract column contains the data that requires translation, and the blue boundary box in the diagram demonstrates the elasticity of a cell, which allows us to store data without string length or field limitations commonly found in programs such as Excel. RapidMiner was used to run sentiment analysis on the translated HP data. The program allows users to run various types of analysis and provides a variety of methods to visualize your findings. However, RapidMiner does have several drawbacks, as it does require extensive sentiment training and restricts table formatting to no more than 2 columns. Despite numerous attempts, we were unable to determine sentiment aside from the raw scores provided within each review. Now let's look at an example of how patterns within the data can help provide insights into business strategy. The majority of our diagrams were created using a business intelligence application called ClickSense. The program managed to pull data directly from the XML file and generated a variety of graphs based on whatever dimensions were selected. ClickSense allowed us to make some insightful observations and correlations within the data. For example, we will briefly examine the printer product category. If we were to approach this from a marketing perspective, we would be able to isolate the printer product category in order to determine how much user feedback was received within each country. In this instance, the US exhibited a high number of reviews, so we then drilled down further to determine how many reviews were specifically for HP printers. In this graph, we have now isolated HP printer reviews from other manufacturers. Since the US had the largest pool of reviews, we wanted to know what contributed to the spike compared to other countries. One approach to determine the root cause is to examine the pros and cons associated with HP printers. Here we can see that the spike was primarily the result of positive sentiment and one negative outlier. Consumers highlighted pros such as ease of use, fast, and good value for the money, but also emphasized a con, noting that the process of printing was too loud. These sentiments were identified as the major contributors to the spike with regard to consumer feedback for this product category. Going back to our marketing example, this information would be extremely useful for a marketing analyst that can now determine what features need to be highlighted or improved, and this information will also assist in future campaigns and designs. Now let's look at a conceptual UI design that allows a user to manage and manipulate the data. When an employee logs into their account, they are then provided access to a set of pre-configured applications for their department. If further customization is required, then the user can simply navigate to the settings panel located within the hub. Once inside the settings panel, the user can add additional features, extend services by enabling API integration, and apply custom add-ons. Chat functions and alerts may also be enabled, where the user may set up specific thresholds that automatically alert them of an issue based on a predefined set of conditions. The alert can not only prevent issues from occurring, but can also prompt the user with information on who to contact in the event there is a specific person or department that oversees an area that may be impacted. After an application has been customized, it can either be downloaded to any device with a browser installed for optimal performance, or ran directly from the hub. All custom configurations are saved in each user's settings panel, where multiple versions of an application can be saved and downloaded at any time. The main interface controls in this example have been predefined. If the user wishes to customize the controls by adding sliders or additional buttons, then this can be accomplished in the user's settings panel located within the hub. Located on the left is a scrolling settings panel where different dimensions of the data can be selected. If a dimension such as products is not displayed, then the user can simply tap on an empty field to display additional dimensions and select a dimension they would like to add. The attributes associated with each dimension are automatically displayed when an item is selected. The user can configure each dimension by tapping on the item and checking or unchecking an attribute from the list displayed. Once each dimension of the data is configured on the left, then the user may apply their filters using the application menu located on the right. One or more filters may be applied by simply tapping on the item to display a check mark, which indicates that an item has been selected. In order to optimize the area within the interface display, a second layer of dashboard items can be accessed from the tab located at the bottom of the display. By selecting a product on the main screen, for example, a user may elect to drill down further and display the data in another format. The dashboard allows the user to display data in a variety of standard charts and in grid view, which displays the data as a standard spreadsheet. In dashboards, the user can still apply all of the standard interface controls and select or deselect constraints or filters they would like to display. They can also drag and drop multiple charts or duplicate charts and simply select each chart to apply different constraints. In addition to the controls we've already covered, the user may select the field located directly above the display to easily add and navigate a category they feel is important. In this example, the field is populated with the names of companies that are represented within the data. By simply swiping across this list, the user can select data that applies to one or more companies, which allows the user to draw comparisons between their products and those of their competitors. By simply tapping each company name, the data can easily be removed or applied to all of the charts and models selected. The last two items to discuss are the search field and the home button. The search field allows the user to locate any keywords within the data. It provides the option to add a keywords filter to the settings panel located on the left by simply typing the word and adding it to the menu. If the word pricey appears, then the user has the option to display the frequency it occurs and can select various dimensions it relates to, such as product, country, or date to visualize the data. A visualization of a word search can be displayed in a chart or in a grid view spreadsheet, which will summarize the frequency of occurrences by category. The Home button is the last feature. This button simply returns the user to the hub, where they can make further modifications, save their work, and exit out of the system. On behalf of my team, I would like to thank you for your time and consideration, as this concludes our presentation for Project 1.